Volcanic eruptions influence the climate, and we are currently feeling the effects of this here in Europe. In this video, we reveal the most violent and consequential eruptions in world history. And believe me, some of these eruptions have effects that will really last for a long time. From massive underwater volcanoes to dormant supervolcanoes. Today is going to be really explosive, so make sure to stay until the end. Welcome everyone. The power of volcanoes has fascinated humanity for thousands of years. If you are as enthusiastic about the enormous power of these fire mountains as I am, then leave a subscription for the channel right away. It costs nothing to subscribe. You won't miss any news and you'll help me reach my goal of 100,000 subscribers. It also helps me a lot if you recommend the channel to others. Thank you so much, guys. Volcanic eruptions can dramatically affect the global climate. From massive ash clouds to tsunamis, the consequences can be devastating. Let's start with one of the most recent examples, the 2022 Hunga Tonga Hunga Hapai eruption, which as we now know continues to affect our climate today. On January 15, 2022, an enormous volcanic eruption shook the earth. The Hunga Tonga Hunga Hapai, an underwater volcano in the South Pacific, erupted with an intensity that was unprecedented. The eruption cloud reached a height of up to 58 kilometers. And besides a relatively small amount of sulfur dioxide, an enormous amount of water vapor was pumped into the stratosphere. Footage from back then takes my breath away every time, I must say. Look at this raw force of nature that is raging here. Especially impressive are the lightning strikes that we can see. A perfect example of a volcanic thunderstorm, a phenomenon where lightning and thunder occur in the ash cloud of a volcanic eruption. It is created by the electrical charging of volcanic ash particles, which are ionized through friction. In principle, it is similar to a regular thunderstorm, but triggered by the friction of volcanic particles. Just a brief note on that. Today, we are mainly interested in the water vapor. It was blown into the atmosphere by this eruption. Because of that, you might wonder whether this has an impact on the climate. We know that volcanic eruptions in the past have had a significant influence on climatic conditions, in some cases across the entire globe. The Toba eruption, for example, which took place 74,000 years ago, was one of the largest eruptions in the history of the Earth and led to a significant cooling of the global climate, known as the volcanic winter, which lasted approximately 6 to 10 years and lowered temperatures by up to 3 to 5 degrees. Now I can already hear the winter fans among you cheering, "Great, then it will get colder again." Unfortunately not. The peculiarity in this case is that because we are talking about an underwater volcano here, it mainly blew out water vapor, which unfortunately has the opposite effect in the atmosphere, and such an exceptionally large amount of water vapor has potentially profound effects on the Earth's climate. Now, a new study by scientists from the University of New South Wales in Australia has examined the long-term effects of the Hunga Tonga eruption. And believe me, the results are quite something. Dr. Martin Juncker, one of the researchers involved, says, "Our results show that the volcano can explain last year's large ozone hole and the much wetter than expected summer of 2024, and the eruption could have lasting effects on our weather for years to come." The researchers used data from NASA's Aura microwave lymph sounder instrument and the whole atmosphere community climate model to simulate the effects of the water vapor anomaly caused by the eruption. The scientists describe it this way: "We ran two simulations with the same climate model. In one, we assumed that no volcano erupted, while in the other, we manually added water vapor to the stratosphere with the amount of 60,000 Olympic swimming pools. Then we compared the two simulations, knowing that any differences must be due to the added water vapor." Simply because there was much more water vapor than aerosols in this eruption. Let's break this down further so we can understand it correctly. Normally, volcanic eruptions cool the Earth's surface by releasing sulfur dioxide, which becomes reflective aerosols in the atmosphere. These aerosols reflect sunlight back into space, thereby leading to a cooling of the Earth's surface. A well-known example from recent history is the eruption of Mount Pinatubo in 1991, which lowered the global temperature by about 0.5 to 1 degree. By the way, 1991 is also my year of birth. However, I have rather warmed the global climate since then through constant CO emissions. Oh well, the Hunga Tonga eruption was different. It released only a small amount of sulfur dioxide, but injected an enormous amount of water vapor into the stratosphere. Water vapor is a powerful greenhouse gas that traps heat in the atmosphere and thus potentially contributes to the warming of the Earth's surface. The new study from Australia uses chemical climate model simulations to assess the long-term impacts of this water vapor anomaly. And what have they found? The simulations show that the water vapor anomalies caused by the eruption lead to a strong and sustained warming of the northern hemisphere land masses during the boreal winter. At the same time, cooling occurs over Australia during the Australian winter. These temperature changes can persist for several years, and it is a remarkable finding that the surface reaction to the water vapor anomalies is more complex than a simple warming caused by greenhouse gases. The researchers found that regional circulation patterns and cloud feedbacks play an important role. In certain regions, such as Scandinavia, this leads to cooling despite the general warming trend. The crucial point of the study is the observation that large water vapor anomalies can increase surface temperatures in large parts of the world by more than 1.5 degrees. At the same time, some regions may experience cooling of up to 1 degree. The North American and Eurasian landmasses are particularly affected in winter, as well as the Arctic, which has shown unusual warming throughout the year. So during the warm summer last year, the Hunga Tonga eruption was at least partly to blame. And well, we don't need to talk about this summer. I can already hear it raining outside again. But Hunga Tonga could also have its share in this moisture. The water vapor in the atmosphere creates a short but intense effect that disrupts the climate significantly for a few years. In the southern hemisphere, the cooling over Australia was particularly noticeable, while the Amundsen Sea in Antarctica was warmer than usual. These temperature changes were caused by a combination of direct greenhouse effects of water vapor and complex interactions with regional weather and climate patterns. And it gets even crazier. Hunga Tonga eruption could influence the climatic phenomena El Niño and La Niña. The study sees a connection between the water vapor anomaly and sea surface temperatures in the tropical Pacific. I had already made detailed videos on El Niño and La Niña, but here's a brief recap. The El Niño Southern Oscillation, or ENSO, is a climatic phenomenon characterized by periodic fluctuations in surface temperatures in the tropical Pacific and has significant impacts on global weather. There are phases of El Niño with warmed sea surface temperatures and La Niña with cooled sea temperatures, which each cause different weather conditions. You're currently likely heading towards a La Niña phase again. And the water vapor anomaly in the stratosphere caused by the eruption likely has an influence on ENSO. Specifically, researchers believe that the water vapor leads to warming of the tropical Pacific, and thus to global climate anomalies. We see that the eruption of an underwater volcano in the small island nation of Tonga has massive effects on the entire planet, and this will last for years. I find that incredibly fascinating and will keep you updated on all findings. Subscribe to the channel now to not miss it. While the Tonga eruption clearly affects the climate, it does so for a limited period. There have also been eruptions in Earth's history with much more dramatic consequences. The Toba supervolcano in Indonesia caused a global catastrophe years ago, and its history is closely linked to the evolution of humans. 2001. Volcanoes are some of the most fascinating formations our planet has to offer. Molten rock, gases, and particles from the Earth's interior reach the surface and offer tourists from all over the world a unique Instagram experience. Just recently, Mount Etna in Sicily erupted again, creating some truly stunning photos. I've been to Mount Etna a few times and I'm always fascinated by the stinking fumaroles, the dark lava caves, and the flora and fauna that can thrive on such a magma monster. However, all these volcanoes are nothing but small steaming incense smokers compared to the so-called supervolcanoes. This is a term used to describe volcanoes that are capable of releasing enormous amounts of lava and ash when they erupt, which have the potential to have far-reaching effects on global climate and the environment. In contrast to most conventional volcanoes, supervolcanoes are characterized by their exceptionally large calderas, a type of crater that is formed by the collapse of an empty magma chamber. It's like with YouTubers. There are the regular YouTubers, and then there are the super YouTubers who create real tremors on the internet with their videos. Of course, I see myself that way. Well, let's forget that. We all know what's going on anyway. Famous examples of supervolcanoes include Yellowstone in the United States and the Phlegraean fields near Naples in southern Italy. An eruption of a supervolcano would have catastrophic consequences for local and global ecosystems. The release of large amounts of volcanic ash into the atmosphere could have a significant effect on the climate, including global cooling. However, such events are very rare and fortunately only occur every few 100,000 years, so we don't have to worry about that for now. But let me know in the comments what you think would happen if Yellowstone erupted now. What kind of impact would that have on the US? Or even the entire Earth? Write it in the comments. Another supervolcano is the Toba volcano in Sumatra, and it changed the world with its eruption half an eternity ago. The eruption from over 74,000 years ago is considered the largest eruption on Earth in the last 2 million years. The recent eruption of Etna was just a small earthly burp. Researchers estimate that around 2,800 cubic kilometers of volcanic material were ejected into the air during the Toba eruption, and up to 2,000 megatons of sulfur dioxide reached the stratosphere. But I can already hear some of you sighing. Dude, what are we supposed to do with such numbers? Okay. So, to give you an idea of how much volume 2,800 cubic kilometers is, you can take a look at Lake Constance. It holds only about 48 cubic kilometers. So we would need about 58 Lake Constances. And to account for the amount of material that the Toba volcano ejected into the atmosphere, this amount of material formed a kind of iron veil in the atmosphere, through which sunlight could no longer pass freely. And the consequence was that less sunlight and warmth reached the Earth, causing the Earth's climate to cool by up to 3.5 degrees for several years, leading to a volcanic winter.
Winter is coming.
But the fact is that it didn't get as severe as in Westeros. And that little bit of winter did not lead to the extinction of humanity, as researchers found. And the fact that I am standing here now somehow proves it. So the cooling by a few degrees back then did not lead to the extinction of the entire species. Quite unlike today, when just one snowflake is enough to bring all traffic to a standstill. There were other factors that were far more dramatic than the cooling. One really devastating consequence for the environment and life concerned the ozone layer. Sergei Osipov from the Max Planck Institute for Chemistry in Mainz and his colleagues have discovered how the eruption of a supervolcano could have affected our ozone layer. And the findings are, to put it mildly, alarming. Just to reiterate, the ozone layer is a region in the Earth's atmosphere that contains ozone in higher concentrations than in other parts of the atmosphere. It extends approximately 10 to 50 kilometers above the Earth's surface in the stratosphere. This layer plays a crucial role in protecting life on Earth by absorbing a large portion of the harmful ultraviolet radiation from the sun. The ozone layer is essentially like sunscreen for the Earth. And as we know, it is important to always apply sunscreen in the summer, folks. Even though I unfortunately never stick to this rule either. In any case, the ozone layer absorbs most of the shortwave UV radiation from the sun, especially the dangerous UVB and UVC rays. This prevents this radiation from reaching the Earth's surface, which is crucial for life on Earth. UV radiation can cause skin cancer and other health problems in humans, as well as damage to animals and plants. And the ozone layer, as a protective entity, helps to minimize these risks. Thank you, dear ozone layer. However, in the case of a massive volcanic eruption, a small problem occurs in the mentioned layers, as Osipov explains. To create ozone from atmospheric oxygen, photons must break the O2 bond. But when a volcano releases large amounts of sulfur dioxide, the eruption cloud blocks sunlight. This impairs ozone formation, creates an ozone hole, and increases UV exposure. The researchers wanted to know what the ozone layer might have looked like after the Toba catastrophe, and used an Earth system model from the Goddard Institute for Space Studies to investigate the extent to which the eruption could have damaged the ozone layer. As already mentioned, it was assumed that around 2,000 megatons of sulfur dioxide were emitted and hurled into the stratosphere and then distributed mainly around the tropical belt. And the result of this simulation is truly alarming. The aerosol veil in the atmosphere was so dense that the ozone levels were reduced by 20%. It is even assumed that there may have been a collapse of the ozone layer in the stratosphere in tropical areas. Osipov says, "Our calculations suggest that the ozone layer near the equator dropped to less than 125 Dobson units. This corresponds to a reduction of more than half. This means specifically that an ozone hole could have formed over the tropics back then, which is not comparable to today's ozone hole at all." As a quick reminder, the ozone hole refers to a region in the Earth's ozone layer where the ozone content decreases. This reduction in ozone occurs particularly over the polar regions, especially over Antarctica, and the ozone hole was first discovered in the 1980s and has since received significant scientific, political, and public attention. And the main cause of the hole in the ozone layer is the release of chemical compounds such as chlorine and bromine compounds that come from US humans because they are used in industrial processes or in products such as refrigerators. In the stratosphere, they are broken down by UV radiation, and the released chlorine and bromine atoms lead to the destruction of ozone molecules. Of course, efforts are being made against it, but our current ozone hole has not completely disappeared yet, and it is expected to take several decades for the ozone layer to fully recover. The depletion of the ozone layer due to the Toba eruption or the ozone hole at that time must have had a really serious impact on humans because of the enormous increase in UV exposure. Researchers assume that it increased by 140% to a UV index of around 28. By way of comparison, the UV index in Central Europe in summer is generally between 5 and 8, which is classified as moderate to high, and at that time it was 28. I don't want to imagine what that could have meant for the people back then. Or for the sunscreen industry, which is probably annoyed it didn't exist at that time. Because a UV index of more than 10 is considered extreme according to the World Health Organization. It is very likely that people back then could have had damaged or inflamed eyes or skin rashes from sunburns and inflammations after a short time outdoors. These high levels of radiation must have led to an increased cancer risk and also weakened the immune systems. Researchers assume that these changed environmental conditions must have led to a significant decline in the human population in the affected areas. Currently, the Toba volcano is still considered active, but it shows no signs of an imminent eruption. Volcanologists naturally monitor such volcanoes closely to detect changes in their activity and to develop early warning systems in case the activity should increase. Nevertheless, one might ask the question, what if the Toba volcano were to erupt again today? This would have significant impacts on the environment and global civilization. A volcanic winter would occur again, which would have serious consequences for our agriculture and food supply. The areas on Earth are today much more densely populated than they were back then over years ago. Such an eruption would therefore claim countless lives and damage the existing infrastructure for decades. Additionally, the volcano could also cause long-term ecological changes, including the loss of biodiversity, changes in the ecosystem, and potential impacts on the oceans. And of course, not to forget the rising stock prices of sunglasses manufacturers. That would actually be a good James Bond plot. Mato, a villain triggers the eruption of the Toba volcano and has previously bought stocks in sunglasses companies. Well, that doesn't sound so exciting. From Toba, we now shift to one of the most famous supervolcanoes, Yellowstone. In recent months, researchers have made some disturbing discoveries there. Magma chamber is behaving differently than expected, and if that thing erupts, we can say goodbye to all climate models. Yes, if you Google Yellowstone, you now mostly find information about the series Yellowstone with Kevin Costner. Let me know who among you knows it. My wife always watches it, and I then watch with one eye. But I sifted through all the Kevin Costner pictures and found the new exciting information about the Yellowstone supervolcano for you. Because the new annual report of the Yellowstone Volcano Observatory, abbreviated YVO, has just been published. And furthermore, volcanologists have really explosive findings regarding past lava flows and a potential eruption. Hold on tight. First of all, the Yellowstone supervolcano is located in northwestern Wyoming and extends into parts of Montana and Idaho. The Yellowstone Caldera, a gigantic volcanic depression, was formed about years ago by a massive eruption of rhyolite magma that spread ash over large parts of North America. This eruption was truly significant and is one of 3 catastrophic eruptions that occurred in the last 2.1 million years. Yellowstone really belongs to the Champions League of dangerous volcanoes. So to speak, the volcanic crème de la crème. By the way, this is how AI envisions the volcanic crème de la crème. The caldera itself is a complex structure that has been shaped by repeated volcanic activity over thousands of years. Since the last major eruption, 28 smaller rhyolite eruptions have further shaped and filled the interior of the caldera. And these eruptions manifested themselves through lava flows that continue to shape the landscape of Yellowstone to this day. Unfortunately, I have never been there, but it is firmly on my to-do list to travel to the USA someday and produce a documentary about the Yellowstone volcano on site. Feel free to write in the comments if you would be interested in that. The more people want it, the higher my motivation would probably be. Make the trip from Cologne to Wyoming. There would be good reason, as volcanologists have now discovered something crazy that has fundamentally changed our understanding of lava flow eruptions in the Yellowstone caldera. Until recently, scientists assumed that the lava flows during past eruptions occurred over long periods of time. New data, however, suggests that multiple lava flows occurred simultaneously or in short intervals. The researchers of the Yellowstone Volcano Observatory have dated lava flow eruptions from years ago, and found that they occurred in close clusters. And that suggests that instead of isolated events, several lava flows erupted simultaneously from different volcanic vents within the caldera. According to the latest research, the 22 volcanic eruptions, known as Central Plateau member rhyolites, occurred in 5 short episodes. Each episode may have lasted up to 400 years, and these episodes, during which 2 to 9 lava flows erupted simultaneously, show that intra-caldera eruptions, i.e. smaller eruptions, in the long-established large caldera are dramatic events, much more dramatic than previously thought. And these new findings, in turn, have significant implications for assessing the eruption probability of the Yellowstone supervolcano. On the one hand, they show that intra-caldera eruptions are more intense and complex than previously thought. On the other hand, they suggest that the long-term eruption rate in Yellowstone could be lower than assumed. If the Central Plateau member rhyolites were formed by 5 events instead of 22, as previously assumed, then this means that eruptions are less frequent but more intense. As geologist Mark Stelton puts it, intra-caldera eruptions are more dramatic than previously thought. Rather than being isolated events with a single lava flow erupting, intra-caldera eruptions appear to be multiple eruptions occurring simultaneously in different parts of the caldera. And what does the new annual report say about the probability of an eruption? This is, of course, what the American geologists are monitoring with the utmost care, because a worst-case eruption would devastate large parts of the United States. Here on this map, you can see how large the death zone and the ash area would be. That would be bad, and that's why monitoring is essential. One of the most important aspects of monitoring the Yellowstone volcano is the analysis of seismic and geodetic data. Between 1 and 3,000 earthquakes are recorded in the region each year, most of which are too small to be felt, but these quakes are closely linked to volcanic activity and thus provide clues to possible changes in the magma reservoir under the caldera. And while the new findings suggest that past eruptions were more intense, there is currently no evidence that a new eruption is imminent. According to the YVO, the rhyolite magma chamber under Yellowstone currently consists of only 5 to 15% molten and viscous material, so there may not be enough magma under the caldera for an eruption. So at the moment, Yellowstone is lacking the oomph for a volcanic apocalypse. Of course, smaller eruptions can never be ruled out. It is always conceivable that Yellowstone could have a smaller eruption without destroying North America and beyond. Said it, 70,000 years ago, the supervolcano erupted with rhyolitic lava flows, and although this eruption changed the geology of southwestern Yellowstone National Park, it was not exactly catastrophic for life on the planet. And although the magma chamber is currently providing reassuring data, a bad eruption can never be ruled out 100%. Science writer Tom Hale writes, "Nevertheless, anything is possible. The surrounding geological layers could collapse, or the volcanic chambers could receive a new injection of magma that revives the monster from below."
If a larger eruption were to occur in Yellowstone today, the effects would be felt worldwide. Large areas of Montana, Idaho, and Wyoming would be covered by pyroclastic flows of hot gas and volcanic material. Estimates vary, but some suggest that up to number people could be killed instantly, and the climate of the entire planet would change drastically. Presumably, a massive global cooling due to volcanic aerosols in the atmosphere would be the result. But if you are already getting scared and want to take out volcanic liability insurance, here's a famous fact from the new annual report of the Yellowstone Volcano Observatory. In addition to seismic monitoring, scientists use GPS and INSAR data, which stands for Interferometric Synthetic Aperture Radar, to measure ground deformation. The more deformation of the terrain, the more volcanic activity. And this data shows that the Yellowstone caldera is currently experiencing a subsidence of 2 to 3 centimeters per year. Volcanologists estimate this as rather low, so it can also be assumed that the magma chamber is currently not experiencing significant magma accumulation that could lead to an eruption. So, peace, joy, and pancakes in Yellowstone Park. While Yellowstone is world famous, a much more powerful volcano, the Apolaki lies dormant in the Pacific, of which very few have ever heard. This underwater caldera overshadows everything we have known so far. It is the largest supervolcano in the world. Let's take a closer look.
Diving goggles on and into the Pacific Ocean. Imagine you are a scientist and are currently examining underwater maps of the Philippine Sea. You scroll through the data, everything looks normal until you suddenly discover a strange structure, a huge circular structure, larger than anything you have ever seen. This is exactly what happened to the Philippine marine geologist Jenny Ann Barreto and her colleagues. They examined images of the seabed east of the Philippines and came across something incredible. A caldera with a diameter of no less than 150 kilometers. For comparison, the caldera of Yellowstone measures only 60 kilometers in diameter.
The newly discovered structure is therefore more than twice as large. Reto and her team named it Apolaki, after the Philippine god of fire and the sun, and believe me, this name is more than fitting for such a giant. But before we find out exactly what Apolaki is and how dangerous it could become, let's first clarify what a caldera actually is. Imagine a volcano that erupts so violently that its entire summit simply collapses in on itself. What remains is a huge crater. This is called a caldera. It is, so to speak, the scar that a supervolcano leaves when it really erupts. Let me know in the comments which calderas you have seen around the world. I would be very interested. The Apolaki Caldera is located on the Benham Plateau, also known as Philippine Rice, about 250 kilometers east of the Philippines. This underwater plateau is truly impressive. It has an area of square kilometers, which is larger than England. And in the middle, Apolaki towers like a sleeping giant. Now you might be wondering how such a magma volcano could have gone undiscovered. Well, the answer is that it lies under 2,500 meters of water. Imagine you are in a large, foamy hot tub and then want to search for your headphones that fell to the bottom of the tub. From above, you see nothing. You have to dive down yourself to find the headphones again. The Apolaki lies so deep beneath the ocean surface, it's no wonder that it hasn't really been explored yet. We humans are sometimes a bit short-sighted when it comes to the oceans. We have more maps of Mars than of the Earth's seabed. The discovery of Apolaki was only possible thanks to modern technology such as high-resolution sonar systems. It's a bit like we finally put on the right glasses to read the secrets of the seabed. The discovery of Apolaki raises a lot of questions. How did this giant come into being? When did the last eruption occur? And when could it become active again? To understand this, we need to take a time travel about 47 million years into the past. Back then in the Eocene, the Earth looked very different. Where the Pacific is today, there was a huge magma chamber deep in the Earth's mantle, what geologists call a hotspot. Imagine this hotspot was like a giant Bunsen burner pushing up against the Earth's crust from below. Over millions of years, the magma chamber ate its way through the crust, creating the Benham Plateau as if it were a gigantic bulge in the Earth's surface. But the hotspot was not satisfied with just creating a plateau. No, it had to go overboard, of course. In a series of massive eruptions, the Apolaki Caldera was formed. Just imagine that. Lava fountains shooting kilometers high into the sky, ash clouds darkening the sky, and a fireworks display that would overshadow even the best New Year's Eve. Researchers suspect that beneath Apolaki there was a huge, shallow magma chamber, almost like an underground lake of molten rock. As this chamber emptied, the ground above it collapsed, forming the massive caldera that we see today. But Apolaki was not finished yet. After the great collapse, a phase of rejuvenation followed. In the center of the caldera, the ground slowly bulged upward again due to new magma entering the chamber, forming what is called a resurgent dome, essentially a volcanic pimple in the middle of the crater. This structure is typical of the largest calderas in the world and shows that there was still magmatic activity beneath the Apolaki. The discovery of Apolaki also sheds new light on the geological history of the region. The Benham Plateau on which Apolaki sits is not just a pile of rocks on the seabed. It is a so-called large igneous province, or LIP, essentially a massive accumulation of volcanic rock. Lips form when massive amounts of magma rise to the surface, often associated with the formation of new oceanic crust. The formation of the Benham Plateau and the Apolaki Caldera could therefore be key to understanding the tectonic history of the Western Pacific. It's as if we have found a huge puzzle piece that helps us complete the picture of Earth's history. But now to the question that is surely on everyone's mind. Should we be worried? Could Apolaki erupt again and send us all back to the Stone Age?
The good news is that Apolaki is probably extinct. Its last eruption occurred millions of years ago. The bad news is that we don't know for sure. The deep sea is still one of the least explored areas on our planet. Who knows what else is lurking down there? Maybe there is still a bit of magma under the Apolaki just waiting to bubble up. But even if it did, an eruption at a depth of over 2,500 meters would be spectacular, but probably not threatening for the entire planet. The water would absorb most of the energy. Nevertheless, purely hypothetically, since the volcano is underwater, a huge eruption could displace large masses of water and cause mega tsunamis. These waves could reach enormous heights and hit the surrounding coastal areas of the Philippines and other Pacific Rim countries. The destruction of coastal infrastructure and cities would be absolutely devastating. Let me know in the comments what you think. Could the Apolaki really still be active, or is it very likely extinct? The discovery of Apolaki is an absolute wake-up call, showing us how little we actually know about our own planet and above all our oceans. We have mapped the moon, sent probes to Mars and taken pictures of distant galaxies,
But right in front of our doorstep in the oceans, there is still so much to explore. The story of Apolaki also teaches us something about the power of science. It took the keen eye and persistence of researchers like Jenny Ann Barreto to find this sleeping giant, and who knows what else we will discover if we remain this curious. The Apolaki may be a sleeping volcano, but it has definitely reignited the fire of scientific curiosity. And perhaps this discovery will inspire a new generation of marine researchers, geologists, and volcanologists. Maybe someone is sitting in front of this video right now thinking, wow, I want to discover calderas on the ocean floor too. So folks, the next time you stand on the beach and look out at the sea, remember that out there beneath the surface, there may be more undiscovered giants like Apolaki sleeping. And if they erupt, it could lead to absolutely destructive tsunamis. To conclude our explosive journey, let's take a look at a mysterious connection between volcanoes and the Earth's magnetic field. For the magnetic North Pole is currently racing towards a supervolcano in the Arctic Ocean. What this means is shown by the latest research findings.
Imagine you are on an Arctic expedition. You pull out your compass to determine your direction, but the needle goes completely haywire. Why? The magnetic North Pole is on the run. Okay, maybe not literally on the run, but it is definitely moving faster than a polar bear on the hunt for seals. For a long time, the magnetic North Pole was a loyal resident of the Canadian Arctic, but for several decades now, it seems to have developed wanderlust.
Currently, it is racing towards Siberia at a speed of about 55 kilometers per year. That's roughly as fast as a turtle in a marathon. So, for geological conditions, that's incredibly fast. And why is this even important? Imagine if all the compasses in the world suddenly pointed in the wrong direction. GPS systems would go haywire, migratory birds would fly around in confusion, and even the door of your refrigerator might suddenly only open on the wrong side. Okay, that last one might have been a bit exaggerated, but you get the point. The reason for this wanderlust of our magnetic North Pole lies within the Earth. Our planet has a liquid outer core made of molten iron and nickel. The movement in this core generates a magnetic field that surrounds the Earth, a kind of cosmic shield against the dangerous radiation from space. It's as if the Earth has its own superhero suit like Iron Man. This magnetic field is not static but constantly in motion. Imagine it like a giant lava lamp, only instead of colorful bubbles, molten metal rises and falls. These movements cause the strength of the magnetic field to change at different locations. Geophysicists assume that the Canadian magnetic field lobe, that is actually the scientific term, has weakened, while the Siberian one has strengthened. Our magnetic North Pole is heading east, as if it received an enticing Groupon voucher for a Siberian wellness weekend or something. But the destination of its journey is anything but relaxing. The magnetic North Pole is heading straight for one of the largest volcanic systems on Earth, the Gakkel Ridge. Wait a minute. A supervolcano under the Arctic Ocean. Yes, you heard that right. And no, this is not a script for the next disaster movie by Roland Emmerich, although it could be a pretty cool film. The Gakkel Ridge, also known as the Mid-Arctic Ridge, is part of the global network of mid-ocean ridges. It extends over 1,800 kilometers under the Arctic Ocean and is the slowest spreading ridge in the world. At first it doesn't sound so exciting, but it is precisely this slowness that makes it so dangerous. It's like leaving a pressure cooker on low heat. At some point, enormous pressure builds up, but one step at a time. In 1999, scientists discovered something amazing.
A huge caldera, a volcanic crater, directly on the back of Gakkel, with a length of 80 kilometers, a width of 40 kilometers, and a depth of 1.2 kilometers. This crater is a heavyweight among volcanoes and can even compete with the Yellowstone caldera. Researchers estimate that at least 3,000 cubic kilometers of volcanic material were ejected during the eruption that formed this crater. This eruption is one of the top 10 largest volcanic eruptions of all time. But don't worry, this eruption happened a long time ago, 1.1 million years ago. The only problem is that in geological terms, that's practically yesterday. And now the magnetic North Pole is moving directly towards this sleeping giant. It's a bit like approaching the ear of a sleeping dragon with a megaphone. What will happen if the cosmic radiation is directed precisely at the Gakkel supervolcano? The magnetic North Pole is not just a point on the map, it is a kind of funnel for energy from space. The magnetic field lines of the Earth converge at the magnetic poles and form a kind of polar dome. This dome diverts charged particles from the solar wind into the Earth's atmosphere, creating auroras, for example. Normally, however, this radiation is distributed over a larger area of the atmosphere, but the area where the Gakkel-backed supervolcano is located is a bit special.
Here, the oceanic crust is super thin. So thin that in some places the mantle is even exposed directly beneath the seabed. It's as if the Earth is wearing only a thin t-shirt here, instead of its usual thick winter coat. When the magnetic pole moves over this area, it could direct the influx of solar energy and charged particles to this thin-skinned, magma-rich region. So, now there are some YouTubers claiming that this will trigger a massive eruption in the Arctic and that we are heading straight for a global catastrophe. The concern raised in these videos is that this additional influx of energy could further destabilize the already unstable supervolcano system. Could this really be true? Let's break this down. First of all, it's not completely far-fetched that the Gakkel volcano could erupt again at some point. The Gakkel Ridge supervolcano has already shown signs of activity in recent years. In 1999, the ridge experienced the largest swarm of earthquakes ever recorded on a mid-ocean ridge. New volcanoes formed on the seabed and even underwater pyroclastic flows. Type of eruption that was thought to be impossible under such high pressure. Another seismic swarm occurred in February 2018, further confirming that we are dealing with an active tectonic system here. And if a larger eruption were to actually occur, the consequences would be rather suboptimal. The enormous amount of emitted material would likely mean it contains quantities of water vapor and other gases that could have dramatic effects on global weather patterns and climate. We remember the eruption of the Hunga Tonga underwater volcano in the South Pacific in 2022, which, as we know today, released so much water vapor into the atmosphere that it changed the global climate. The ash and gases released from a volcanic eruption could not only disrupt air traffic, but also influence global temperatures for decades.
An eruption of the Dorkening Ridge would be a bit like the Hunga Tonga eruption on steroids, but here's the thing, there is no scientific evidence that geomagnetic storms or the movement of the magnetic North Pole can trigger volcanic eruptions. Volcanism is caused by thermal and mechanical processes in the Earth's crust and mantle, not by electromagnetic fields. The connection between geomagnetic storms and geological events such as earthquakes or volcanic eruptions is not completely absurd. After all, we know that the Earth's magnetic field is generated by the circulation processes of liquid material in the Earth's interior, so there is a certain connection to volcanic activity. But there is a complete lack of scientific evidence to support the idea that the migration of the magnetic pole has a direct impact on geological processes such as earthquakes or even volcanism, or that the shifting of the magnetic field could trigger eruptions. Even the force of the solar wind itself is not strong enough. Solar storms affect the Earth's magnetic field and can cause geomagnetic storms, which in turn can disrupt power grids or satellite communications. We still remember the geomagnetic storm in May,
as we were able to see beautiful auroras even in Germany. There is no direct connection between solar activity and volcanic eruptions. The energies released during a solar storm are indeed enormous, but they mainly affect the upper atmosphere and have no significant impact on geological processes deep within the Earth. Overall, both the movement of the magnetic poles and the volcanoes of the Gakkelrücken are super exciting topics that still have much to be explored, but they probably have nothing to do with each other. But other opinions are always valid. Feel free to write in the comments what you think. Is there a connection between the magnetic field and volcanism? Could the migration of the magnetic North Pole trigger an eruption of the Gakkel supervolcano? Please share your ideas in the comments. I hope you are all now true volcano experts. I will of course keep you informed about all future eruptions and discoveries here on the channel, so if you haven't done so yet, press the subscribe button now and complete it. Speaking of explosive discoveries, scientists have just discovered a completely new pattern in nature. These so-called soft cells are everywhere and could revolutionize our understanding of natural forms. To find out what it's all about, be sure to click on the video displayed in the top right. Super exciting. And for cool shirts and other galactic merchandise, feel free to click on the bottom left where you can enter my space shop. Every purchase greatly supports my work, and you will also find fantastic Christmas gifts for nerds in 2021. Otherwise, I would say see you in the next video. Take care, folks.